In this video, I'm going to describe what to do when we get stuck balancing a chemical equation. Because sometimes we get to the end of balancing a chemical equation and we find that one of the numbers, no matter what number we insert somewhere, we're never going to get a whole number to fit here and make it balance. So we're trying to figure out a couple methods to get us past this roadblock. And the first method that I have for us is a fraction method, where we can temporarily insert a fraction or a decimal. Fraction is going to be a little bit better or less confusing for some of you. And that will help us get us past this roadblock. So we can attempt it that way. So let's go ahead and solve this problem. Let's pause this video and try to solve this problem on your own. If you're able to get it, then great, you're ahead of the game. But let's at least set it up and at least go until you get stuck, because we technically haven't learned this yet. And yeah, pause the video. All right, hopefully we got that, or at least we're able to get it set up. We've got CHCl and O, CHClO. We got that on those elements on both sides of the equation. All right, I'm going to count how many of each one we have. We have 2 carbons, 2 hydrogens, 2 chlorines, and 2 oxygens on the left side. On the right side, we have 1 carbon, 2 hydrogens, 2 chlorines, and we have 2 plus 1 more. I have 3 oxygens. So we now need to start balancing. We notice that hydrogen and chlorine are already balanced, so don't need to worry about those. And now we need to decide between carbon and oxygen. So 2 things we might remember from the last video I made, in that carbon is typically one of the easier ones to balance first. So we can remember that and then try to balance carbon first. Or we might say, well, wait a second. Oxygen is here by itself, not bonded to another different element. And carbon, everywhere that it's located, it's bonded to multiple different elements. So I think that second thing that you might notice right there, that carbon is bounded to multiple different elements, but oxygen is not. That is going to be very helpful in deciding that we're going to balance oxygen last and carbon first. So in order to balance carbon first, let's figure out where to add a number. I have 2 carbons on the left side. I need to figure out how to get 2 carbons on the right side. I can do that by entering a number right here. So if I put a 2 there, I now have 2 carbons. But this 2 does not only apply to carbon, it also applies to oxygen. So I now have 2 times 2, I have 4 oxygens from here, plus another one right here. So 4 plus 1, I have 5 total oxygens now. All right. Okay, so now we got to move on to balancing the oxygens. I'm going to notice right away that this has nothing to do with oxygen, so I'm not going to add a number right here. But I need to add a number right here. And I need to decide what number goes there. What number goes there? So I'm asking myself, what times 2 equals 5? And you might think, well, wait a second. There is no whole number that can be multiplied by 2 that equals 5. You might type it into your calculator and you might get 2.5. And that's fine. You can insert that, and then our equation is balanced. But you're going to have to, right after this, you're going to have to figure out that we can't leave a decimal or a fraction in the coefficient. We have to have all whole numbers. So you need to figure out, after inserting a decimal or a fraction here, you need to figure out, what do I multiply this entire equation by in order to make sure we have all whole numbers? In this case, you could take whatever, if you're doing a decimal, you could take whatever's on the right side of the decimal point and divide by that. So if we divide everything by 0.5, that's the same as multiplying everything by 2. If we multiply everything by 2 or divide by 0.5, we're going to get a 2 here, 5 here, 4 here, 2 here, and 2 here. So that's from dividing everything by what's to the right of the decimal, so divided everything by 0.5. Let's say that decimals are confusing. I think that they can get confusing, especially if you're not ending in 0.5. The other thing you could do is you can say, all right, I want a more clear-cut way of knowing what number to put right here. The other way to do that is you could say, okay, what times 2 equals 5? And this might sound a little bit confusing, so feel free to replay it if you need to. But we could say that I'm going to do 5 divided by 2, 5 divided by 2 times 2 equals 5. All right, think about it. 5 divided by 2 times 2 equals 5. So we can always just remember, if we're doing fractions, we can remember what number goes where. So, because you might get to a point where it's hard to figure out what the decimal is. So here we can always just, let's take my highlighter and I can highlight exactly what we're talking about. This number on the numerator comes from right here, comes from that 5. And then this number right here in the denominator comes from this 2. So what times 2 equals 5? Well, 5 divided by 2 times 2 equals 5. And we can do that. And then it's a lot easier to figure out what to divide everything by or multiply everything by in order to balance this out to whole numbers, because we can say that, all right, let's multiply everything by 2 because 2 is in the denominator. If you multiply by what's in the denominator, it makes it not a decimal anymore, or not a fraction anymore. So let's multiply everything by 2 here. So put a 2 here, multiply this by 2, we're going to get 5. Multiply this by 2, we're going to get 4 here and here. And then we have a balanced, simplified chemical equation. Whether we wanted to do decimals or fractions, I'm going to keep using fractions and show you where those numbers come from. But you're welcome to use decimals if you want to get a calculator out and do it that way. All right, let's try one more problem here in this video. All right, using that method that we just went over, I want us to, and you can use decimals or fractions, doesn't matter. I want us to try to solve this problem. All right, so pause the video and come back when you at least have it set up. Preferably, you try to solve it. All right, now that you're back, we have aluminum and we have oxygen. Aluminum and oxygen. On the left side, I have 1 aluminum and 2 oxygens. On the right side, I have 2 aluminums and 3 oxygens. All right, I need to start balancing. We know that metals are a little bit easier to balance than non-metals typically, so let's start with that. We can put a 2 right here, and now I have 2 aluminums on the left side. But now I'm stuck. There's no whole number that I can put right here in order to get 3 oxygens on the right side. I could say, well, what times 2 equals 3? I could say, if you have a calculator out, so you could say, well, 3 divided by 2 is 1.5. You could put 1.5 there, but I'm going to do it that's the fraction way. I'm going to say, well, in the numerator, I'm going to insert this number right here. let's go ahead and highlight both of those. In the numerator, I'm putting a 3 because of this 3 right here. And then in the denominator, I'm going to put a 2 because of this 2 and this 2 right here. So, or you can think about it as, well, what divided by 2, or sorry, what times 2 equals 3? Again, what times 2 equals 3? Well, 3 divided by 2 times 2 equals 3 because the 2's would cancel out. But that's where the numbers come from. This 3, and this 3, this 2, and this 2. All right, so now let's go ahead and multiply everything by the denominator here in order to get this all balanced. So we need to multiply everything by this number. So multiply everything by 2. All right, so when we do that, it's going to look like this. We're going to put a 4 here. We're going to put 3 here. And we're going to put 2 here. 4, 3, 2. We can, it's always good to get in the habit of double checking your work. We now have 4 aluminums. We now have 6 oxygens. 3 times 2 is 6. And then we now have 4 aluminums over here. And 2 times 3 is 6 oxygens. All right, so I hope this method was helpful. If it's not, I have another method that's maybe a little bit less math intensive. If this seemed confusing, feel free to check out the next video, which will cover that. And a lot of people like that concept better. It's this method that I just taught you here. I'm teaching this one first because this method will always work. It will always work no matter what problem you're solving. The next method that I'm going to show will work about 98% of the time, maybe 99% of the time. It'll almost always work, so it's another great method, but there's a slim chance that it might not work. So feel free to check it out. It'll be great for this class. It's plenty sufficient for this class, but once you get to an advanced chemistry class, maybe you might get stumped, and this first method might be better. But check out the next video if you need more additional help. It's covering the same concepts, but a different explanation.